discovery that schizophrenia is actually a disorder. This was released in the media and discovered in the genetics lab in 2014. The genetics study began in 2013 under the guidance of C Robert Clonninger, one of the most prestigious and well-known psychiatrists in the United States. It was discovered in the genetics lab. I forget the method of discovery. It was using some kind of DNA. They examined something around between 3,000 and 9,000 individual subjects for similarities in genetics coding and differences according to an abstract category, and maybe even an abstraction of an abstraction. We are going to be taking a different approach. We're going to be looking at it from the standpoint of deviance, water symmetry, and chromosomes. And the first method we will use is deviance. This is a method that is fairly ingenious, which I invented in 2013, roughly a year before Clonninger discovered his results, and is published on Simple Site, where I discuss the use of tensors, matrices, and mitochondrial DNA, along with other methods I've used to arrive at this conclusion that schizophrenia is a disorder. Indeed, the assertion that schizophrenia is not a single disorder is indeed somewhat controversial in its own right. There are people like Eugene Bleuler, back in the 1920s, who actually believed there was two disorders, meaning there was a disease in the left brain and a disease in the right brain. These two cause conflicting maladies which tend to disturb the patient's cognitive faculties, both in logic and in verbal reasoning. That's why it appears in both men and women. You reason that way. The result was never confirmed. Indeed, has now been shown to be false. Here we go. Now, suppose that we define a schizophrenic as perpetually deviant, and we wish to describe it as a center of mass deviance. In other words, we view the patient as a collection of particles, be it mechanical or electromagnetic, even strong force and or electroweak, and we define it as deviant from a normal person, meaning that there's some type of three-dimensional, maybe even time-dependent parametric curve. In other words, we have x of 1, 2, 3, coordinates 1, 2, 3 in time, y of 1, 2, 3 in time, and z of 1, 2, 3 in time. The three-dimensional parametric curve. I don't know if you can see these three equations. There's x, y, z of their respective coordinates, x, y, z, x of 0, x, y, z, the time, y, and z, and so forth. And time being more or less a parameter as well as x, y, and z. Just a way to define a parametric curve. You can consult textbooks such as what's the name of that book? Thomas Finney by Addison Wesley, Calculus and Analytic Geometry, edition number 7 by Thomas and Finney under the publisher Addison Wesley, for discussion of how to represent a three-dimensional parametric curve. For the sake of discussion, you may view it as controversial or at least controvertible that we use a parametric curve in the usual center of mass equation. You might view it as just a simple differential, some type of differential like delta of x or something, delta x, delta y, delta z. I chose to view it as parametric for a number of reasons. Mainly that I view the person's behavior as a sort of almost like a bumblebee flying around, like you define the person's behavior as slightly deviant according to a curve. In other words, there was an implicit delta x, delta y, delta z for the parametric curve itself, meaning that um, the curve was deviant in and of itself and never was conformal, even at a point. I'm using things like real analysis. This is controversial for the reason that schizophrenia may in fact intersect at a finite countable number of points. For the sake of discussion, this is really not relevant because finite meaning the real line is aleph 1, meaning that if it were countable, it would be aleph null, meaning that the richness of the real line is infinitely more complex or hard to describe than the richness of aleph 0, which is integers. But the point being that even if the schizophrenic patient were behaving appropriately or at least normally at some finite countable number of intersections along the parametric curve, it would still be infinitely less dense and or rich than the actual number of deviances per any section of the parametric curve. So we have a deflection or deviance delta x, delta y, and delta z. And the question becomes, if we were to define deviance as a disease itself and ask the question, what is the degree of richness that this disease has if we were to actually suppose that we're not in fact one disease, but perhaps multiple diseases, we'd be led to the conclusion that we need to form an analysis of delta x, delta y, and delta z. And the point being is that there are those who would say, well, it's just the richness is 3, x, y, z. A more formal discussion and analytic interpretation of richness, degrees of richness, degrees of the matrix equation, the Jacobian, the determinant of these 3 variables, shows that it cannot be 3. It might be 6 or 4, maybe probably 6 is the number of determinants, number of terms in the determinant. And Jacobian likewise, although the Jacobian is coupled in a different way. The point being is that the richness is probably not 3, for the sake being that 3 is not a unique number with respect to the parametric curve deviance because it's orthogonal, meaning that if we were to redefine the deviance as being conformal in one sense, it may be anticonformal in 2 other senses, meaning that using I guess varying coordinates, you can arrive at a solution which is only rich to the point of being 1 or 2 dimensional, even though that the reduced dimensionality would be enhanced thus-wise. The point being that it's not an adequate definition of richness to just say it's 3 things, x, y, z. So what we're going to do is use combinatorics, basically discrete math, to show that the correct number of deviances is 8. We're going to say that if it deviates to the left or to one sort of you should study the T and B frame as presented in textbooks like Thomas Finney's Calculus and Analytic Geometry 7th edition, or Wilfred Kaplan Advanced Calculus 3rd edition, the T and B frame, because it shows you that with respect to some kind of plane which you define as optimal or at least maximally deviant or curling, rotating with respect to the parametric curve, there's a left deviance and a right deviance, meaning that there's a plus delta x and a minus delta x. We're going to say there's like a plus or minus, plus or minus. That being said, the richness is actually just the combinatorial multiplet of what these 3 things represent, without any form of discussion as to whether it's in reduced coordinates or not. Meaning the point is, but using the T and B frame, the oscillating plane, like the T frame, the N frame, and the D frame, the oscillating plane, and the other 2 planes, with respect to the parametric curve, we devised an optimal, or at least maximally rich, and always maximally rich, way of defining a parametric curve of such order. And if the thing were three-dimensional and fairly rich in its variation, you would find that the richness is always the maximum amount. Even though the thing may be, say, the parametric curve were only in one plane, in other words, it only varied in x and y and not in z. Z were just a constant in the equations defining the parametric curve. You would still say that this is never observed in reality. It's unrealistic for a three-dimensional human being to move in a two-dimensional planar way while driving a car, for instance, or walking around his house or apartment or eating food is fully unrealistic. So we're going to say it's at least three dimensions rich. That being said, the correct solution is 2 times 2 times 2, plus or minus, and plus or minus, delta x, delta y, and delta z. And this can be shown in analytic geometry. The proof is not hard. It's just a matter of interpreting the complexity, or at least analytic complexity of the three planes, i.e. the deviance is defined by the three planes. And by the T and B frame, we know that the three planes and or T and B, thus y's, are always orthogonal, even though they're shifting as we move along the curve. We know that the richness is always maximal if you define it generally, and even though at times it may flatten out. For instance, if the patient behaves in only one or two-dimensional way for some period of time, eventually when they'll start moving again in a three-dimensional way, and we'll say that generally speaking, the disease is always the multiplet of the richness of the delta, plus or minus delta x, delta y, delta z. There is no degenerate coordinate system. An example of a degenerate coordinate system is polar coordinates, where you have you can have like a circular orbit where something is moving in a circle. You say it's defined by cosine x equals cosine theta, y equals sine theta. At the same time, you also say that no, this thing is actually just theta equals constant, because you don't have to find the radius that's changing, it's just the angle that's changing theta, meaning it's actually a one-dimensional equation. It's just simplified, yet it's two-dimensional. That's what I mean by degeneracy. Therefore, we see that the richness of schizophrenia is, as predicted, 8 and nothing else. Now we're going to move on to water equilibrium, something I learned about in the cell with Jennifer Lopez and Vincent D'Onofrio and Vincent Vaughn, something called Weyland's infarction, where it's been shown and proven that schizophrenic patients like being suspended in water. When it was first discovered, it was conjectured that the patient was like being reminded of what it was like being in embryo when they were just born inside the mother's womb. What I'm going to show is that by considering the number of equilibrium positions of water in itself in utero and within water suspension in a generalistic sort of loose sort of way, we can show that the number of diseases or disorders, either one, with schizophrenia properly represents 8 once again, using an alternative method. Schizophrenia is, let's assume that the number of pathologies that schizophrenia represents is equal to the number of equilibrium states that water represents, or I can assume, meaning that there's an exact one-to-one correlation. One is never greater than the other, and the two are always equal. This is easy enough to think about. It's just, you can imagine a person having having a part of his body on fire, having to put it out with water. Well, maybe that's a bad analogy because it sounds confusing, but you treat it with chemicals, say, for a burn. So you imagine the number of points on his body. You can have a theory for how rich the pain is. By the number of points, you can say this is a skin disease or disorder, so many points, depending on how many different point spots that are putting medicine on his body. Likewise with water, you can say that the number of pathologies which schizophrenia represents is the number of equilibrium positions of water. You may wonder why it's equilibrium positions and not something like reduced surface temperature or something like that, or why that isn't an added dimension. You should just assume that in utero, the baby, and even in room temperature water, the surface temperature doesn't really play a role. And at first, a lot of people would be inclined to think that, oh, the number of equilibrium positions of water suspension is just one, with buoyant force upwards. But that's not in utero. In utero, there is no buoyant force, so you can scratch that. But you might also be inclined to think that it's two, just leaning to the right or leaning to the left, re-equilibrates you. But upon richness of analytic nature, likewise in the previous discussion on equilibrium points of deviations from a parametric curve, you can, by the same argument, reason the number of equilibrium positions or restoring forces, the richness of dimensionality in as an equation, the number of variables per se, or the degree of the polynomial, whatever. Actually, it would be one less because of the constant, but you can say that the richness is likewise equal to 8 once again. There's a left position, a right position, a forward position, a back position, up position, and a down position. You may, people might say, oh, there's like combinations thereof. The point is that you can always reduce it to a simplified coordinate system, and this is optimally the only one you can reduce it to, and it's always optimal for any general number of vector displacements or equilibrium displacements, meaning that even if you were to shift coordinates, you would still find on average for the vast number, even maybe even very much even countably infinitely more dense number of coordinate systems you choose, you always have a richness of 8. The dimensionality will always be 8. So many people are, once again, like as with respect to the parametric curve, inclined to think the dimensionality of the richness, the dimensionality of water equilibrium is 3, just x, y, and z. You have to remember there's a left position, a right position. There's 2 positions of equilibrium or disequilibrium for every dimension of water. So if the water is 3-dimensional, you have 8 different positions, not 6, not 3, not 4, 8. The richness is 8, meaning you have to use combinatorics because it's a combination of the 3 forces, restoring forces with respect to the coordinate system. Moving on to codons, we can see that collectively, if we were to assume that a codon is a simplification for a unified genetic map or instruction for, say, something like neurotransmitter functioning or organic functioning, or what Abraham Hoffer and Nobel laureate like to refer to as an orthomolecular behavior instructions. We can see that what schizophrenia being age disorders is telling us about codon, being the number of codons is 3, the number of deviations per set of 3 codons, which constitutes an allele or a gene, is actually just 8, meaning that schizophrenia is evidently only with respect to one chromosome, three chromosomes as a gene with respect to an entire set of genes with the end programs, a organ, a neurotransmitter, or a orthomolecular reaction, meaning that collectively all the genes act in sequence and collectively as the same thing, meaning that all that schizophrenia is collectively is a deviation in 3 different ways on 3 different chromosomes in one gene. That's what it appears to be telling us. There is, of course, the possibility it could be influencing genetics or the manifestation of genetics on 3 different genes on 3 different chromosomes at the same time, meaning richness would still be 8, it's just that it would be on different genes. I don't like that theory. It's less aesthetic. You tend to think of it as more collective and centered. It might be true that maybe only the first chromosome on each gene for a particular organ affects, for instance, neurotransmitter, and the second one affects organic functioning, and the third one affects orthomolecularism. That might be the case. I don't like it. It's just some food for thought. What I'd like to discuss next is the eight disorders which schizophrenia represents, which I postulated incorrectly in 2013 as hearing, seeing, inner ear, or rather inner ear, eye, heart, lung, and so forth. Just a collection of what schizophrenia was often most held to be, like, hallucinations, delusion, maybe skin temperature for tactile hallucinations. My new modified theory says that much more intelligently. It says that the disease is most likely a parasympathetic and a sympathetic manifestation of a sex disorder, an eating disorder, a heart disorder, and a breathing disorder. One, two, three, four in sets of twos for sympathetic and parasympathetic. 2 times 4 is 8, or rather 4 times 2 is 8. 4 different pathologies in 2 different ways. Breathing, sex, heart, and breathing, sex, heart, and eating. And that's fairly believable. Honestly, those are all fairly common things which are very addictive and unnecessary, which affect the individual very strongly. That's why I prefer them for my description of what schizophrenia properly is. Breathing, sex, heart, and eating disorder manifested in both parasympathetic and sympathetic ways. I very much believe that this is the correct interpretation of what schizophrenia is. And to close out the lecture, what I would like to present is something I read about in Feynman, physicist Richard Feynman, about Yang-Mills theory, and that the collective matrix for Yang-Mills is represented as a tensor, a 3 tensor, which only has 8 terms because the 9th term is optimal, has to be discarded because it represents the total energy of the system. It's just sort of vague wandering into the proposition that quantum chromodynamics or quantum electrodynamics may be at the seat for what is going on in schizophrenia, either through something like quantum tunneling, a few other quantum effects, or just some kind of mass sort of uncertainty principle like influence of molecularism and submolecularism over the organism as a whole. I think that's very speculative. I don't like to venture forth on strange scientific advents like that. If you understand how much garbage has been released on quantum entanglement and quantum tunneling in the last 30 to 40 years, it doesn't make any sense what people are saying those things can do. This might be true. I've often toyed with the idea that schizophrenia may be some kind of quantum gravitational disease in which the strong force is left out where the other two are still active, meaning that you have, instead of a 3-dimensional chaotic influence upon the organism, you only have a 2-dimensional variation of what correct behavior is, meaning in actual truth, schizophrenics can handle chaos and randomness well. And that's a strange assertion because most psychiatrists would tell you, oh, they handle chaos very well. They don't handle order well. What I'm saying is that schizophrenics can't handle chaos because they can't make order of it, whereas the normal person can make order of chaos because they have all 3 forces, gravitational, electrical, weak, and strong, working for them to resolve using cognitive faculties which are made possible by second quantization of quantum field theory, the versal C, the Heisenberg uncertainty principle, and quantum gravitational fluctuations in the tensor field of which gravitation induces. All three of those four of those collectively induce a form of randomness, which by the Heisenberg uncertainty principle has to create a great deal of order at certain spots. This might very well prove to be the hallmark of what schizophrenia really is. Think about it.